Let's talk about the difference between an array and a pointer. It's pretty critical here. In the last video, we have ship verts here. We're trying to make it a member of MyGame, and so we just kind of slammed it up here. And then in the constructor, we're trying to get the data in there somehow. And why? Well, we can't put an assignment out here. C++ does not allow you to assign anything like so. I know C# allows you to do it, and I believe Java does too. And all they do is take that and put it in the constructor, is what C# and or Java does. Okay, syntactic sugar. Out here, we're defining the layout of a MyGame class. We don't write code out here. Actual code that executes goes inside of functions, and the constructor is simply a function. That's all it is. It's just a function that's automatically called when you create an instance of an object. And so I put our code here. This assignment, this is an operator. It's something that does something. I actually put it here in the constructor. So why am I going to all that effort? Well, I want shipverts to be part of my game class. Now here's where the compiler gets hung up. The compiler sees, oh, we have shipverts here, and that's fine if you're going to make shipverts a member of my game, but me, the compiler, I have to determine the size of a MyGame instance. When you create a MyGame instance, what you do, or we will, in main, it is the size of whatever's in a renderer, and the renderer has some arrays of some things in there, plus the size of one pointer, plus the size of another pointer, plus the size of this array. So what is the size of this array? We haven't said out here, and if we don't say, the compiler assumes the array is size 0. Well, we don't want an array of size 0. We want an array big enough to hold 3 vector 3D so we can get our data in there. So I could say, let's just make it 3 there, but that's a magic number. So let's say static const uint num ship verts. Before we derived this value here, we derived it, I believe, by using the size of operation. Num ship verts, we did size of here, but I can't say size of something here. I'm actually trying to create the array size. Here we say, well, what's the size of the array? Tell me, and I'll figure out what my number of shipverts is. But here, it's like the chicken and the egg theory. I can't. I need to tell the compiler the size. So here we're going to be explicit and say, hey, it's 3. All right, it's 3. So I want 3 vector 3Ds. That will be our shipverts. So this creates RAM inside of the MyGame instance. Let's say we have a MyGame instance here, and we create it on the stack. I'll say MyGame instance. We create it on the stack, which we will do in main. We'll just instantiate one of these on the stack. It's sitting on the stack, and it has room for 3 vector 3Ds. So 3, and vector 3Ds are floats, so 3 times 3, that's 9 floats times 4 bytes per float, 36 bytes. So here's 36 bytes of the MyGame instance sitting on the stack. And what I wanted to do is take all these vertice positions and somehow get them in there. Right? It almost looks like I can do that with the syntax I'm using in the constructor over here, where I say, hey, ship verts array gets all that stuff, but we can't do that. That's not legal. In fact, the syntax is illegal by having the brackets on there. I'm going to just, let's see what the compiler says about all this. Control KC. I think we're good. Let's build and see what build errors exist. Holy smokes, lots of build. It's complaining here. Expression must be a modifiable L value. Huh? What's a L value? Well, an L value basically means there's RAM I can modify. Okay, and it can go on the left-hand side of an assignment operator. An R value is just, hey, give me a value. I can pull that value from RAM, or it can be a literal. In 98, that's a valid R value. I can read that and figure out what the value is, but I can't say like 98 gets 62. Okay, this is not a modifiable L value. See, this expression must be a modifiable L value. You're trying to change what 98 means. There's actually a language that allows you to do this. I can't remember which one, but holy smokes, if 98 equals 62, say this was your bank balance, then I would say, hey, 98, that's fine. Let's make it worth a lot more. Anyway, that's why the compiler's complaining. It's saying, hey, shipverts. Shipverts is the name of this array here of floats of bytes inside of the MyGame instance. You can't modify it. here it's a pointer. It's a pointer to this thing right here. You can't modify it to point to this structure, which you're trying to create on the stack somewhere else on the stack. That's not legit. Right? That's why the compilers complain. It's like, oh, what a headache. You know, this is the part where I see people cry about C++. Like, oh, I just want to get something done and I don't understand what the compiler's doing, which is true. This is complex. Okay, you probably have to watch the videos, watch this whole refactoring thing a few hundred times and understand all of it. But once you get it, you just got to do it a few times. So what are we going to do? Oh, well, I'll tell you what we're going to do. Vector, Control U, Control Shift U, Vector 3D, ship verts. Let's call it ship vert data array. Right, and we don't have. Oh, I need to put the using here. I need the using for vector 3D. Using math vector 3D. So now that's there. And I'm okay doing that because we're in a compilation unit. You should understand that by now. So this is defined on the stack, okay? This is also on the stack too because we'll create it in RAM, but it's on a different section of the stack. So we have all of this ship data, the 0 and the 0, 1.44, all that data. Here's the 0 and the 0.1414, yada yada. All these floats are sitting right here, and essentially what we have to do is copy them into the actual array that makes up our MyGame instance. Alright, now just a side note, I could make MyGame in main on the stack, which we will, but I could instantiate it on the heap or make it part of the program image. Doesn't really matter. What I want you to understand is this RAM is different from this RAM, and this RAM has the data I'm trying to shove over there. So how do we do that? Well, there's this nice little C function. Let's pound include C standard library, and I'm going to say memcopy. Copy the memory. Where am I going to copy it to? Well, I'm going to copy it to the memory represented by shipverts. Shipverts is when I say shipverts, that's the address of the first byte of this vector 3D floating array. So send it to shipverts. And the source is going to be shipvert data, which is sitting on the stack. And then the size. How big do you want it to be? I can say size of shipvert data, or I can say size of shipverts, either one, because the compiler knows the size of both of these, and size of here will return the number of bytes that these take up. Alright, now if this was a pointer, if I did vector 3D pointer, gets new, and I made this an array and all that out on the heap. Well, now taking size of shipvert data, the compiler says, oh, it's a pointer. That's all I can see. All right, let me really stress that here for you. It's a pointer. I can't even see the stuff it's pointing to. I don't know the length. I don't know any of that. All I can see is it's a pointer, and so that'll be 4 bytes. Not what we want. We want the size of shipvert data. Let's do it statically. By statically, I mean the compiler can make a static analysis or analyze it and figure out the size. Whew. Are you as tired as I am? I'm exhausted. I hope you're not getting burned up by all the technical details here. There's lots of them to keep track of. Okay, we're good. That's the shipverts. Let's do the indices. Same thing here. Static const uint num ship indices. I hit control space there, hoping the IntelliSense would finish naming my variable for me. But alas, IntelliSense is not that good. Nor would I want IntelliSense to try to be that good. Use short ship indices. It will be the size of num ship indices, like that. And then same deal here. Use short, and this is kind of weird, defining the memory on the stack, then copying it in, and that sort of thing. Well, we're going to start. Eventually, we'll start pulling data from files and configuration files, and really change up the dynamicness of our program. But use short ship indice data array gets real simple. 0, 1, 2. The ship was easy, wasn't it? I believe it was the boundaries that got interesting. The same thing here. Memcopy. The destination is going to be the ship indices, the memory inside of the MyGame instance. Ship indices. The source is going to be this array right here, sitting on the stack next to us. And then the size is the size of ship indice data. Okay. Wow, so that was a lot of work, but that will copy this data out to here, or I guess out to here, and then this data out to here. And now we need to send it down to OpenGL. Well, send it down to our renderer, let's just send it to OpenGL, and hopefully the renderer will draw. We'll see.